Hi, my name is Elizabeth Cloud. I'm a PhD student in the Learning Sciences and Educational Research Department at the University of Central Florida. Today, I will be presenting a paper titled How Do Emotions Change During Learning with an Intelligent Tutoring System, Metacognitive Monitoring and Performance with MetaTutor. Before I get started, I'd like to thank my fellow co-authors for their tremendous assistance in developing this paper. And I'd also like to thank the National Science Foundation and the Social Sciences and Humanities Research Council of Canada for funding this research. Before diving in, however, I would like to provide a brief outline of what I'll be covering today. First, I'd like to talk about the empirical evidence that suggests emotions are related to learning, and also discuss relevant theoretical frameworks that we use to guide our research questions, the information processing theory of self-regulated learning, and the model of affective dynamics. Next, I'll be talking about the methods, so our sample and the measures we used, the intelligent tutoring system that the students learned with MetaTutor, as well as our coding and scoring procedures, our research questions and their findings, and last but certainly not least, how we can draw significance from the findings to inform the design of intelligent tutoring systems which are sensitive to the affective experiences of students in order to promote effective emotional regulation and ultimately foster higher performance and self-regulation. So a number of studies provide empirical evidence that emotions impact learning with advanced learning technologies across a range of contexts, and domains, where positive and negative emotions influence learning differently. However, mixed findings in literature suggest that not only do both negative and positive emotions relate to more learning processes and strategy use during learning, but also negative emotions are linked to higher performance. Yet some studies suggest differently, such that negative emotions are related to less self-regulation and ultimately less learning. So the lack of clarity in the role of negative emotions on learning begs us to ask a question which might offer more insight into this complex relationship, such that how are emotions captured and defined in literature while students learn with advanced learning technologies? And after sifting through the literature, it became very obvious that one of the most traditional methodological approaches has been administering self-report questionnaires either before or after learning. And also other methods have involved observations of students learn emotions during learning, and more recently, facial recognition software that also captures emotions during learning. However, we argue that there are still major gaps that exist in literature when studying emotions, since theoretical frameworks and their underlying assumptions explain emotions as dynamic and fluctuating states that change over time during learning. And as far as we could tell from the literature, there aren't many studies that define emotions and capture them in this way to define them as potentially changing over time. And so we used two theoretical frameworks. First being the information processing theory of self-regulated learning, because it describes learning as a cyclic, nonlinear process that occurs over time. And we also used the model of affective dynamics because it explains how and why emotions arise during learning with technology and defines emotions as dynamic and fluctuating experiences of which depend on not only the learner, but also the information that they are learning about. And so I'd also like to draw some attention to the negative emotions in the model of affective dynamics. The first being confusion, then frustration, and of course boredom. And these all have a bidirectional relationship with one another, and how these play out, such as if a student is confused, if they cannot resolve their confusion, which ultimately stems from an impasse in the information they're learning about, then it will lead to frustration and then ultimately boredom if left unresolved, and ultimately negatively impacting performance and learning. And so these theories guided the objective of our study. And so we sought to capture confusion, frustration, and boredom at 3 time points during learning to examine relationships between how these emotions might have changed or not changed and the relation to metacognitive monitoring and performance after learning with MetaTutor. And so we captured a sample of 117 college students, predominantly female and Caucasian, from 3 large North American universities, where the mean age was 20 years old, and we compensated participants $10 an hour, lasting up to 2.5 hours. Upon receiving informed consent, we randomly assign students to one of two conditions, the first being the control and then the experimental being the prompt and feedback. I will touch on more details of the experimental design and the conditions on the next slide. Materials we use to capture our variables, the first being performance, was pre and post-test assessments to gauge students' understanding of the circulatory system. We also used the emotions value questionnaire, which was administered approximately every 14 minutes using a 5-point Likert scale. I don't provide much details on this questionnaire. However, if you are interested in finding out that information or if you have questions, please feel free to contact me. I will provide contact information on the last slide of the presentation. We also use processed online trace data to capture metacognitive processes, and I will touch on that later in the presentation as well. So MetaTutor, let's talk about MetaTutor. MetaTutor was designed to teach students about the human circulatory system using 47 pages of text and diagrams. It was also built with 4 pedagogical agents that were each designed to mirror human tutoring interactions. Specifically, they are designed to foster self-regulated learning, and they use tools built into the interface such as the SRL palette you can see over here on the right, where students can plan their learning, they can monitor the understanding of learning, and also initiate cognitive strategies such as taking notes and summarizing by selecting the icons on this palette. Now, students in the experimental condition, the prompt and feedback, were required to initiate certain SRL processes via this SRL palette from the pedagogical agent. So they would prompt students to initiate certain SRL processes based on time and event-based production rules. And they also were provided with feedback, the students, for feedback on their performance throughout the learning session from the pedagogical agents, whereas in the control, these students didn't receive any sort of feedback or prompting from the agents compared to the experimental. And however, the emotions value questionnaire was administered approximately every 14 minutes across the conditions, so that was consistent. Now, the experimental procedure, it was a 2-day study. The first day, students came in and they completed self-report questionnaires and a pre-test to assess their knowledge of the circulatory system. On day 2, they completed a 90-minute learning session with MetaTutor, and also they completed a post-test to gauge their understanding of the circulatory system. Now for this paper, we analyzed multi-channel data, the first being the number of times that students initiated metacognition using the SRL palette, which was captured using online log files that were initiated using the mouse. So we captured the total frequency of times that they initiated those metacognitive processes. And we also captured self-reported emotions approximately every 14 minutes during the learning session and performance outcomes. Now for our coding and scoring procedure, to define emotional changes, we used 4 EVs, data captured at 4 time points at 0 minutes, 14, 28, and 42 minutes. We assigned students to groups based on whether or not they had increases, decreases, or no changes in their emotions based on their initial EV. So for example, the first time point that we captured changes was between was differences or increases, decreases, or no changes in EVs from 0 to 14 minutes. So that generated 1 time point, and then the same for 14 to 28, that generated another. And then the last time point was between these 2 administrations. For performance, we defined it using the total number of correct items over the total number of items in the assessment, generating ratio scores. And last but certainly not least, the metacognitive monitoring accuracy. We specifically targeted judgments of learning that were initiated on the SRO palette between the conditions. So students who had initiated judgment of learning, I'm just going to skip next to the next slide to show you what it kind of looked like. You can see here that students, they prompted their JOL using an icon on this palette, and then they were presented with a list of questions or items that they had to respond with which most they agreed with. So I'm just going back here to show you that students rated a 1 as being that they strongly believe they did not understand the information, and 6 was that they strongly believe they didn't understand the information of the content on the page in which the JOL was initiated. Following their reporting of their judgment, they completed a 3-item quiz based on the information on the page that the JOL was initiated. So we computed an accuracy score, which was based on how aligned a judgment was with their quiz performance. And this was 50% of the score, and we allocated 25% to the actual quiz score and then another 25% to their JOL rating. And as you can see, students in the performance or prompt and feedback condition had 27% accurate metacognition, whereas the control was 59% accuracy here. Yes, and so moving on, what did we find? Well, we found in our first research question, we wanted to see, of course, if there are relationships between metacognition, accuracy, and post-test scores. And we ran a partial correlation controlling for pre-test scores and condition. And we found a significant positive relationship between metacognitive monitoring accuracy and post-test scores, as you can see here in the correlation. Next, we wanted to see if there were significant differences in how emotions changed over the 3 time points. And so we ran 3 separate chi-squares using a Bonferroni correction, 1 for each time point between the groups in their self-reported ratings. And we found that there were significant differences in emotions and the distribution of emotions across 3 time points, as you can see here. Next, we wanted to assess the extent at which there are relationships between changes or no changes in the emotions across the 3 time points and post-test scores. So we ran an analysis of covariance, 3 to be exact for each time point, with a Bonferroni correction while controlling for pre-test scores and condition. We found significant differences in post-test scores between groups which had demonstrated increases in boredom from 0 to 14 minutes, which were negatively associated with post-test scores. We also found that no changes in confusion from 0 to 14 minutes were also negatively related to post-test scores. Next, we needed to see if there were relationships between emotional changes over the 3 time points and metacognitive monitoring accuracy. So we ran 3 ANCOVAs, 1 for each time point using a Bonferroni correction while controlling for condition, as there were no differences in monitoring accuracy for pretest, so we didn't include that in this. And we found that there were significant differences in metacognitive monitoring accuracy scores between groups with increases in boredom that occurred from 14 to 28 minutes, which were negatively related to their accuracy and metacognition. Specifically, this effect was only present for students in the control condition. So there was a significant interaction here, which we did not see in the experimental condition. So how can we use these findings to inform future research and drive implications? Well, first, we found positive relationships between metacognitive accuracy and post-test scores. And this is consistent in previous literature who found the same thing, and also the theoretical framework of the information processing theory of self-regulated learning. We also found that emotions did change over time during learning with MetaTutor, which is consistent with the model of affective dynamics. Moving on, we found that post-test scores decreased when boredom increased from 0 to 14 minutes. This was found in a similar study by Baker and colleagues, and it's also aligned with the model of affective dynamics, where we see that if students are bored, they're disengaged from the material in which they're learning about. Additionally, we found that if confusion did not change from 14 to 28 minutes, there were decreases in post-test scores, which was also a similar finding in Wertha and colleagues in 2019. And it is aligned with the model of affective dynamics, where you can see here that if confusion is occurring, then they are experiencing an impasse in their learning. And if it's left unresolved such that it does not change, then it might be leading to frustration and further, the student is unable to resolve that impasse and they're stuck in understanding the information, the materials. Now, next, we found that metacognitive monitoring accuracy decreased when boredom increased from 14 to 28 minutes, only for learners in the control condition. Now, this was a similar finding by Baker and colleagues in 2010, and it's also found in DeMello's and colleagues in 2014, and is consistent with the model of affective dynamics. And so how can we use this information to inform future research? Well, it is very critical to capture and define emotions as temporal changing dynamics, which might impact learning. And we can use multimodal data to inform when an emotion might change further, such as eye gaze, pinpointing what were students looking at and how might that have contributed to changes in emotions. And we can use this information to build intelligent tutoring systems which are sensitive to the affective experiences of learners, and we can build multi-agents to promote effective emotion regulation strategies. And so here are our references. I'd like to acknowledge the Smart Lab at UCF, NSF, as well as SHRC in Canada for their funding, And if you have any questions, please feel free to email me at the email here. Again, thank you so much for attending this talk, and I look forward to hearing from you. Thank you so much.